So we've all been to classes where you can go and you can listen to the guy drone on, or the female instructor or the male instructor, whoever they have up there, and drone on, and there's some PowerPoints, and if you memorize those, you can pass the test. Well, this class is a little different. This one you have to do this stuff, and when you're doing homework, you have to try it, you have to experiment. If you don't, when you get to those assignments and you wait till 9 o'clock on Sunday, which hopefully you will not do, you're going to have a problem. It's not going to run, you're going to have an error, and you're not going to know how to solve that. You haven't seen it, you haven't experienced it. So this class, you really, let me throw another really in there, need to do this material as you go through there. So we're going to do stuff outside of this book, but this book gives us a framework. So there are literally hundreds and hundreds and hundreds of resources out there. And I have contemplated even doing this class without a book, but it seems like, at least for some of us, that we need that framework of, here's something I can hold in my hand that makes life a little better. So what I would like to do, though, today, at least to explain it a little bit, is one of the resources we want to put in place then is things outside of this book. This book covers a small subset of topics, but depending on what you want to do with Python, this barely scratches the surface of what Python can do. And so your discussion board task this week is we are creating a resource list of tutorials, helpful sites, other things that you can find for resources for Python. So a couple of things about this. You can't duplicate what other students do. You can't use python.org. We know that that's the authoritative site, but it's not always the easiest site to understand. You do not have to respond to fellow students. This is really just creating a resource link of places that you can go. So on Sunday, when suddenly you're going, oh man, I really have to get this homework done, and my instructor emailed and he's out driving somewhere and he can't help me and I got to figure this out, this is another resource list that we can use. So, a couple of points in there. Make sure when you create this, you put that resource in the title of your discussion board. If it does not have it in the title, it does not score. How about that? You can come back and edit it, and if I don't have that turned on, I can do that really quickly from here. But you also need to look at that resource. Go in and try some of the things in. A lot of these resources will have coding little insert boxes where you can actually try some of the samples in there. I will caution you that one thing you will run into is there is a lot of material that is in the version 2 of Python versus version 3. So I would encourage you to look and make sure that it's version 3. There's a lot of reasons to look at version 2, but I don't want to confuse you by having two different print statements, for example, and different things. So look for ones that are 3 dot something compliant. I actually looked at, have any of you guys heard of like Udemy and Coding Academy and some of those sites? You can actually go through and do courses in some cases fairly cheaply. And I looked at some of those sites for Python and other resources. And one of the things I found is a lot of those still are trying to teach in 2.7 or 2.8 or whatever the latest version of 2 point something is. That's great. It still gives you a lot of the same concepts, but I think we should probably concentrate on the latest and the version that's actually moving forward. So, no duplicated. Duplicated resources don't get credit. And, oh, I actually said I will take off 3 points if you don't put it in the title. It just makes it easy for your fellow students to not duplicate. But go in and look at those. You will start to see some really amazing resources out there. And so go in and look at them. Sometimes you'll go, wow, this is better than my instructor will ever manage to tell me about how to do a while loop in Python. Or you might find a shortcut or a trick or a technique or something that you'd like to use and that may come in handy. And some of you may use this outside of other things. So I know we have at least one math major in here. We're going to pick on you now. And in math, a lot of times we use things like R. And so there are techniques that you can learn in Python that you can apply to R, which, do you want to tell us what R is real quick? Have you had to use it yet? Oh, okay. So there are a lot of different math modeling languages and different programs. R happens to be an open source, free one that has at least as much power as some of the paid tools like SPSS and some of the other statistical software. So, but the same techniques we use in Python can apply into those. And so data science is one of those areas that's growing significantly in its value and where they want to compensate you or not. So we have a lot of material we're going to cover this week. So we're going to talk all about things like branching. We're going to look at how do we create a loop. And I think the loop is probably the most important thing we have in any programming language, because that gives us that power to do things iteratively. In other words, we do them over and over again. And it's something we're not really good at, but our computers are. And so how we distinguish those becomes really important. So if you will join me, and I always feel weird when I start typing or anything because I feel like I'm sunk down and you guys can't see me. So jump up and yell, throw things at my head if you have a question, because I can't really see you with the sea of monitors in here. So I'm going to open up, the very first thing, I'm going to open up an idle window just so I have one available. And remember the difference between interactive mode and script mode or batch mode. And so in our book, starting on chapter 3, it says, oh, we're going to learn how to use random numbers, we're going to use if statements, we're going to use while loops. And notice at the bottom it says, oh, and we're going to introduce you back to our friend, that pseudocode. In other words, how do I plan a program? So we're going to do a couple of things in here to start with. But one of the first things I want to try to do is we need to figure out how to import libraries. And so I'm going to go ahead and put a comment tag in. Do you guys want me to share out the screen onto your side again? Does that help? Okay. Let me do a couple of quick things here, and I will see if I can get that shared out. I want to make... that one to be the main display. And now I can share that out. All right. Now you guys should see my blue screen, hopefully. You see the notepad? Sweet, okay. I am also going to try to make that as big as I can so you guys can see it. So 24, maybe too big. All right, let me try it a little smaller. Let's do that and see if that we'll see. All right, so all right. Just because it's easier and I can blow it up, I'm going to put mine in Notepad. You are welcome to use Notepad. It takes me one extra step in here compared to using the idle environment, but I can make it bigger so you guys can see it easier. So the downside to that is it doesn't color code. So notice if I use a hashtag, it color codes it here. It does not color code it when I'm using Notepad. So just be aware of that. Drag that out of the way. So the first thing I want to do is I'm going to put in my name, and that's just going to be a standard. I'm going to say, that way I know your program, I know what it is. And this first one I'm going to do is I'm going to talk about import libraries. So importing libraries is pretty tough. I'm going to type import, and I'm going to type the library I need. And in this case, the first library I'm going to use, and we do it quite often, is we're going to import a library called random. And random, the library random, gives us the ability to add all kinds of random functions. at it. That's not very tough. But it's not loaded by default. We have to actually say we're going to import that. And so if I come over here and you see it in, oops, I lost my, too many windows open. So I need to have that import in to be able to utilize that. So if I have import in, I can generate random numbers. And so I'm going to do something here. And most of you have played with dice. Maybe you play games like Farkle. Maybe you go play craps in a casino. Whatever it is, we all understand what a dice looks like. Well, I'm going to assign a value to a dice. So I'm going to call it die 1 or dice 1. And I'm going to assign it a value, and I'm going to use the key phrase random. And remember, we're using those dotted things a lot, and we're going to put in .rand. So we're assigning it something, and we're going to put it in that range of 1, 6. So in this case, I'm going to then print, and I'm going to print out dice, let's call it die 1 is, and then remember at the end of our programs we always want that open input statement so it holds it open. All right. So all that does is it just sits there and waits for some kind of an input. So I'm going to save this. So File, Save As. And since I'm in Notepad, I have an extra step. And you could certainly do that. So I'm going to put mine under Documents, under my Python, and I am going to call this my die.py. And I have to go to one more step down here. So Notepad always wants to save it as a text document, which it really is inside. But Python doesn't recognize text documents. It says it needs to be a Python file or .py. So I'm going to change this save as type to all. So if you're using Notepad or another program, you can do that. And I actually put the extension in manually and said .py. And so I'm going to save dice.py. So now, what I don't have in Notepad, normally if I'm in my program, I just hit F5 and it runs. I don't have that ability to do that when I made it a little bigger. So I'm going to come over here, and I'm now in my folder where that's at, and I can see the program, dice.py, and I am actually then going to just click on it to run. Or I can edit it. I must have done something odd in there. All right, so in this particular case, I have, now we see it in Python, so it's highlighted. So, and notice import shows up as orange. That's an odd color. I haven't seen that one before. And here I've got die1 equals random range of 1 to 6. I've got die 1 is blank, and then I've got an input here at the end. So nothing exciting, but we're going to see if that actually gives us a. So we have an error. So it gave me an error of some sort. So I'm going to look at this and see if I can figure out why it does not like my particular thing. And if I look here, maybe I need to change that a little bit so it says random range of integer. And so now I'm going to save it again and run it. And notice now it says, all right, die 1 is 1. If I rerun that, hopefully we get a different number. But notice we're getting the same number twice. So we need to do some investigation. Oh, there we go. We are getting different numbers. So in case you do something, you do always want to run this and make sure you don't have something odd going in there. So what this does, so this piece here says I'm calling the random function, and I'm calling the integer, so I'm getting a random integer between 1 and 6. So that's a really handy way I can do that. I can also do it a couple of other different ways. And so let's examine if we had 2 dice. So if we're going to play craps. So I'm going to set up die 2, and I'm going to set up random dot. And now instead of an integer, and notice what happens inside of the Python, makes it a little interesting. Notice it actually pops up the different options that I can have. And I'm actually going to click rand range. And now I'm going to put in the value 6. And I'm going to copy this down because I want to see what die 2 is. And I'm going to change that just slightly. So now I have dice 1 and dice 2. I'm going to get numbers out of those. Yes, I'm going to save it. I'm going to run it. 2 and 3. Okay. But what I'm looking for, see if I can get it to do it. And it's not going to do it quickly for me. Aha, there we go. So that took me a little bit. But what I'm showing, notice it says die 2 is 0. Oh, is that the numbers we're looking for on a dice? No. And so the tricky little piece with that, with doing it this way, we're saying we're going to get 6 random numbers, but where does that computer always start counting? 0. So if we do it this way, we have to increment it 1 so that it will be 1 through 6 instead of 0 through 5. So just a little quirk. Quite frankly, you can usually use this random integer, and that will work fine. There's some other ways we can do it if you need decimal numbers, but in this case now both of those would work. So die 1 is 1, die 2 is 5. Great. So we could create our dice, and now we could have the beginnings then of a craps game. Or, I mean, a game that you could play that's similar to craps. So maybe some of you, if you're super nerdy, has anybody in here played Dungeons and Dragons? Nobody's raising their hand. Oh. Nobody has played Dungeons and Dragons. All right, so there are other games, but Dungeons and Dragons is the one that always comes to mind. If you've played it, you have dice all the way up to 20-sided dice and odd things. If I wanted to simulate a 20-sided dice in Python, all I would have to do is change this from 1 to 6 to 1 to 20. I could do the same thing doing it this model. And now I have 2 dice that have up to 20 different sides. Well, if I can simulate those numbers, maybe I can create some other values. Maybe I want to create a value for a random test score. So maybe I can change my program a little bit. I'm going to get rid of this. I'm going to leave it as dice just so we can see what would happen. But maybe I wanted to create a random test score from 1 to 100. Oh, somebody got a 91. Well, that's pretty good. Oh, they got an 18. So maybe this score is random for whatever reason. Can I create a score that's just between 80 and 100? Let's see. What happens if I put in, instead of a 1 to 100, if I do this so now I'm creating a set of random values between 80 and 100. So it would be odd to give you guys all B's or A's based on a random score, but there might be some validity to that. But in this case, I needed a value between those. I can now generate a list of random numbers. So page 51 talks about the import statement and the library that we're importing. Now, they tend to call them modules. I call them libraries. They're the same function. 52 also looks at the random integer and the rand range functions. It also tells you why you would add that 1. Now, generally, I'm not going to have both types of functions. I would only have one type of function in there. So if I decided that I wanted to do this, the rand integer, what I would really do is I would use the same function. I wouldn't switch. And dice2 would then become, I would use a similar function. And it doesn't make any difference in there which one I do. So, in both cases, they give us a similar result. Now, I will warn you one weird thing. So you're thinking, all right, I'm ready to write a program, and I'm ready to go complete a completely random number. And these numbers that Python generates with this model are actually what we call pseudo-random numbers. We have a fairly good chance we could guess what's going to happen. They're not purely random. So we have some better techniques if you're writing video games. But this works really well for us to start and get us introduced to the idea of how do we create random numbers. And if we combine this here fairly quickly with a while loop or some kind of a loop, we could simulate. We can start doing those things like Monte Carlo simulations where you simulate what happens if I roll a dice 10,000 times, what kind of values do I expect to see? And we can actually do it with 2 dice, and we can start to see how the odds on something like a craps game get developed. One of the other things that was really handy when we started working with pseudocode is we started looking at the ability to do if statements. So some kind of a logical operator was a really, really handy thing. So I'm going to change my program a little bit here. So I'm going to go back here so you can see it a little easier, what I've got going on. I'm going to leave the random in just for now. And I'm going to leave the input at the end, but I'm going to delete everything else, and I'm going to file, save as, and I'm going to call this program password protect. And remember, I have to call it .py because I'm in my text editor. And I'm going to call this password protect. So I'm going to put a couple of things in here to start with. And I'm going to put a print statement in, and I'm going to say, welcome to Cybersecurity 101. Oh, we're getting there. All right, so I'm going to use a statement in here, and I'm going to let somebody put in a password. So I'm going to create an input. So I'm going to say password equals input. Please enter your password. And I have now a password that they're going to put in. I want to figure out if they've got the right password. So I'm going to hard code in one, and I'm just going to shortcut it here. So I'm going to create an if statement. So if password. Now, here's where I did something a little different. Notice I used two equal signs. So in a comparison operator, if I want to say something is equal to, I actually use two equals. If I use a single equals, it's that assignment operator, and it's putting a value in. And so two equal signs are going to tell us that we're asking, is the question of, is password equal to whatever I put in here? And I'm going to use the phrase secret, just because it's easy. And I'm going to say, is password equal to secret? Now, I'm also then, I have to go down a line and indent, because I'm going to have a set of block of text that is going to run if that is correct. And so if that value turns out true, all right, so everything that I have in here in this indented block is going to run if this password is indeed typed in there correctly. Now, I'm going to save this really quickly. So File, Save. And notice I have it over here now. So it's going to show up in my file. So Password Protect. I'm going to open it in idle just so we can see what it looks like in there. And notice now all our color coding is back. And notice, oh, that orange shows up again on if. And we're indented here. So we've got several of our steps. So now we can actually run this and see if our program works. It doesn't do a lot. All we're doing is making one comparison. Please enter your password, and I'm going to type it correctly the first time. It says you're granted access to nuclear secrets. Great. I'm going to run it again and see what happens if I put in the wrong password. And notice it doesn't give me that line here. You are granted access to nuclear secrets. Bless you. So the if statement is pretty powerful. It looks at, is this condition true or not? So if this condition we've created is true, then everything inside this block of indents will work. And I could actually put in almost an unlimited number of those if I wanted to. And this could be all different kinds of other code. It's all going to run. So if I put in the right password, it's going to run everything inside that block. So that could have been other statements, could have been all different kinds of logic. So on the bottom of page 55, it talks about those comparison operators and the difference between the equals and the double equal sign. So that is one of the things that I often see when people start coding in here, is you'll start looking at an if statement, you'll go, whoop, nope, you have an assignment operator, not an equals. So equals is this double equal sign. On page 56, there is a table of all the operators that we can use, or the common ones anyway. So, and it's even got some sample conditions in there. So the one that is different that you may not have seen is the not equals to, and we use that quite a bit. So we can compare even strings, we can compare numbers, we can't compare strings and numbers together. So I can't compare. Here I'm comparing a string to a string, but if I had a number in there, it would break very, very quickly. Bottom of page 56 talks about those indentations. Now, here's the reality, though. Is a password going to be that easy? Is it just buried inside a text like that? No. Generally not. If it is, then we have some serious other issues. So our program can expand a little bit. If statements, before we use them in pseudocode, we know there's really two sides to it. I can do all these things if it's true, and I can also do things if it turns out false. And so on page 57, they start looking at the else clause. Oh. So we can actually create an else clause. So I'm going to come back, and I'm going to type else, just so we'll see if it'll show up. And notice what happens on else. Else also highlights as orange. It's at the same level as this statement and this one are at the same indentation level. This block is going to run. And so at the end of an else statement, I'm going to indent, and I can print, get away, you do, let me make it a little better, you do not have access to any secrets. And so now I can put in a statement that's going to happen if you don't get your password correct. And just for emphasis, I'm going to put it in here several times. This is how we roll our security. And so we know if I type secret, it's going to say you have access. If I type secrets, it's going to say get away, you do not have access to any secrets. So we have both sides of that if statement. So we have this part as if it's true, this part if it's false. So those if statements are pretty powerful. And then I can actually put things inside of those. So I can nest those if statements if I need to. But I also have something that's even more powerful. This is kind of a cool statement that we're gonna work with, something called elif. So we're going to extend the power of that if then else statement, and I'm going to create a brand new one here. I'm going to delete all this other gook. And so I'm going to start with a blank program. And I am going to create a program that is going to tell what my mood is. Oh. I am going to cheat a little bit on this program. And here is the reason why we're going to cheat just a little bit. I'm going to go into my source for chapter 3. And there is a mood computer. And I'm going to open it to edit it. I am not going to copy the entire program. What I am going to look at is I am going to copy in those ASCII arts. So I don't want to have to recreate that ASCII art. It's in your book, and you can certainly try to do that. That's the part that I'm going to say is probably really okay to copy. So if I look at this program, and I'm going to leave it up here so we can see what the completed program is, I want to go through and see if I can create something similar. So I'm going to print a statement, and normally at the beginning of all your programs, mood computer. So I'm going to shorten that up a little bit. And I want to get a random mood. So in this case, I'm going to have up to 3 different moods. And so I'm going to say mood is equal to random.rand integer 1 to 3. So I've got a variable now that says I have a possibility of being 1, 2, or 3. And so I'm going to set up some if statements. So my first one, I'm going to say if mood is equal to 1, I'm going to take action 1. And I'm just going to put a comment in there and say action if mood is 1. I know then that I can come in and use another value, and I'm going to use this elif. And notice it lights up orange. All right. So otherwise, if mood now is equal to 2, and I'm going to just mark that so I can see what it is. Action if mood is a 2. We also have a third option. So LF mood equals 3. Action if mood is a 3. So we've got the logic blocks down. Now we just need to put our content in there. Yes? Yes? Yeah, no, not a big issue. Sorry. It's just a comment tag to let me know what I'm doing in there. So I now have 3 of them, but I'm going to do one more thing in there. I'm going to print or look at, remember we have an else statement. And we're going through them, and I think we did that, set it up right. But let's do this catch-all. If that mood shows up as any other number, because we made a typo or an error, we're going to have a catch-all group. And so we can end it with an else. So any other condition is going to trigger that else statement. And in that case, I'm going to go ahead and just print a statement that says, somehow you broke the computer and got an illegal mode. Now, the reality is that should never happen. That line should never get utilized. But it's a safety mechanism, so in case I screwed up here, so maybe instead of using random integer, I did something else, or I accidentally put a 4 in there, my logic isn't safe, then I will be able to use that as my escape clause, and the program won't come crashing to a halt, and it'll actually work very nicely. So I'm going to copy these print statements over just because I don't really want to recreate that. So print number 1, I'm just going to copy it. And that's going to be for mood 1. I'm going to come over here and copy 2. And again, I'm just grabbing the print statement. And I'm going to do number 3. All right. Now I'm going to save and run that. What have I done? Probably when I copied something, I did something weird. Where did it show me? And, oh, I actually did it right down here in my own print statement. I did not put a ending parenthesis or a quote mark in there. All right, now we'll try it again. So now, when I run that, it goes, oh, I'm unhappy. I run it again, and now I'm happy. So this is just getting a random, now I'm unhappy again. What I'm hoping to do is generate at some point, and it says, oh, somehow you broke the computer. Because I have an error in here, and I did it deliberately, where I put that 4 in there. So I can go, oh no, I should never have that. But again, it's a great safety mechanism to have that as an option. That way if I do make an error up here. So one thing I'm going to try, just out of curiosity, I'm going to go ahead and I can always cancel out a line when I'm troubleshooting with that pound sign. And so I'm going to put a pound sign in front of that import random, and I'm going to see what happens if I try to run this without that library being directly imported. And when I do that, it actually tells me random is not defined. Darn it. So we do have to import that random. That gives us some of those functions. And now our program, I went back in and I fixed it so it should never, no matter how many times I run this, it should never, ever, ever have an issue. Now, if I go back into my file folder, and I look at this same program, and I want to run it, well, now I could actually run it a couple of different ways. So notice, and I've got it at the wrong name, I can actually run it directly from my File Explorer. And it gives this weird black on white text. So we're able to run that program. We don't have to go into idle to run it. You can actually just run that program directly. If I did not have this statement at the end, that input that just stays open, that program would close immediately. And I can show you that if I put in a pound sign. We eliminate that input statement. And I save this. So you saw it work before, and now notice it just flashes on the screen. It doesn't stay open after the program runs. It just ends. So that input statement here is what we use to hold that open with. And so now if I run it, I get my happy face back. So when I look at this, could I have added additional moods? Yeah. And I can use nearly an unlimited number of elif statements. So I could have one for happy, sad, neutral, angry, and if I'm willing to put the art in, I could come across with almost any of those. So elifs are a great way we can ask multiple questions. So remember a long time ago, most people grabbed a game and they said, I want to do rock, paper, scissors. And we didn't really have a great way to handle something more than just a yes or no question. Well, now with this elifs, I can handle those really easily. So I could do a rock, paper, scissors, and I could do those comparisons pretty easily. So elifs, page 62 talks a lot about elifs and has some information about it. And then on page 63 there is a summary of how we can create loops. So one of the things we could do is we could write our entire program then in a loop, which we're going to show you here in a second. So we've got if, then, else statements. Now we're going to talk to you on how to put loops in. So if you haven't had the experience of a 3-year-old, we're going to recreate what it's like to have a toddler right here on your computer. And so a toddlers tend to be a little obnoxious and they'll drive you a little crazy. So I'm going to start a new program. File, new. And again, just so it's a little easier to see it as I type, I'm going to go ahead and leave the import random in. We may use it here in a second. And I'm going to put in a couple of print statements. I'm going to print, welcome to the special place a toddler lives. All right, so I'm going to do a couple of things to start with. I am going to put in a variable, and I'm going to call it response. And I'm going to assign it a value immediately. And I'm going to give it a blank. I'm going to say that there is no content yet in that response. Well, I am going to create my while loop. So I'm going to put the phrase while. So we're doing a while loop, and a while loop runs as long as the condition is true. And so we're going to say response does not equal because. So everything inside this next indented line is going to run as long as this is still true. So we're indented in a line, we can run, and now I can actually get an input. So response equals input y. And just to make sure it shoves down a line, we're going to come across. So this loop, as long as you don't type the phrase because, it should run nearly forever. And so we're going to try this out. At the end of this, to make sure that we say that we're really out of a loop, I'm going to put a print statement. You survived. Now, I'm going to save this, so File, Save As. I'm going to save it as a .py file. Save. All right, so now that I know it's in my folder, I'm going to pull it up with Edit, with Idle, and that will allow me to see what the highlighting looks like. And this is a loop. And so one of the things I might want to do, let's make sure it works first. So I'm going to hit F5. Welcome to the special place a toddler lives. Why? And this is going to run no matter what I put in, unless I put in, oh, I had to spell it. Helps if I spell it right. And until that errors out on that loop, so in other words, until the response actually was because, that flips this false because we said as long as that response is not equal to. Now, there's other ways we could do that, but this is just a handy way to show that loop. We didn't know how many times, so it's an indefinite loop. We don't know how many times that loop is going to go. We can actually put inside of here, we could do a counter. And at the end of that, then we could print counter. And so if we wanted to check and see how many times that loop ran, we could do this. something strange. Not sure what I did there. So we could put a counter in, and we could count the number of times that loop runs. It doesn't like whatever I did there. Something I did. Tabs or spaces. Oh, weird. All right. So counter equals counter plus 1. So this time it's we actually have a counter in there, and so until I in the loop, it says you survived, and it just tells me, hey, that loop ran 7 times. However, 1, 2, 3, 4, 5, 6, 7. All right, that seems right. Now, that gives us some power to do that. That century variable, in other words, what that loop is based on, we have to have some way for that to change. If I didn't have this input in right here, if I just had a print statement, I could make that loop run forever. So let me just do this. I will go chunk. So we eliminate that, and I'm just going to put a print statement in. And so now all it's going to do is say the question why. So there I've just created what's called an infinite loop. There is no way for that program to ever end. I don't have the ability to change that variable that it's comparing to. And so it's going to run until I finally decide to break it with a Control-C. So if I wanted to, what I could also do to even just to see what that variable looks like, I could put my print counter right here. I don't know why it's being picky about my stuff, but whatever. Counter, print counter, print counter. So you can see how quickly it can count up. And in a couple of minutes, it's going to be in the thousands, outputting those. And again, there's no way to get out of it. We took away the ability to change that loop. Now, if I wanted to base it on counter instead of on that response, I could do that. So while counter, I could change it this way, and I could say, while counter less than, let's say, 100. And now I could see what happens. And notice that it exits that loop after it runs 100 times. So I got the ability to create a loop. I can modify what its sentinel value is. So I can base it on either a number, I can base it on an input. So as long as I can change that, so page 66 talks about avoiding those infinite loops. And so they actually have you create a program, and it does something very, very similar, and it dies. And so you can find that one if you wanted to. That program is called Losing Battle, I think. And so if I run it, it does an infinite loop, the same as what we just did. There's no way to change that sentinel value, and that's a really common issue. So if I look at the code, so it says, while health is not equal to 0, there's no way to ever change health. So you'll see that we have some issues with that. So that one is also an example of a bad program. We're actually losing the ability to control our program by doing that. And so you can see the code for it. You can create it. And so here, you could trace it out if you wanted to. So health is equal to 10, while health is not equal 0. Health equals health minus damage. But what happens is this one's actually a little trickier. Why is this one an infinite loop? I'm modifying the value here, health, right? I change it here. So remember, that's a shortcut way to say health equals health minus damage. So the first time this program runs, health is equal to, it starts at 10. So 10 is not equal to 0, right? The next loop through it says, so it took out 3, that's what damage is. So the next loop you have 7. 7's not equal to 0. Next loop, you subtract another 3, so 4 is not equal to 0. Next loop, you subtract another 3, so 1 is not equal to 0. But the next loop through, what happens? Well, you have 1 minus 3, so is minus 2 equal to 0? So one of the things you can do is you can put in those test statements. So we could put in the test of print health. And so you can do that. Put in these temporary print statements and see what your values actually are. So if you look at that, that goes negative. It's never equal to that 0. So a simple change in this program, so while health is greater than 0, and now the program works. And it's those little logic errors, especially with those comparisons, that will drive you a little crazy. All right, so the rest of the chapter, so we start looking at how do we do some other things. So we look at those comparisons and we start creating a math model that we can work on those. So this one runs. So now, if I look at what happens, it says 10, 7, 4, 1, and then it actually, the program exits out of that loop. So you always want a way out of that loop. If I'm not changing that, so in this case we are changing that sentinel value, so we had that part right, but we weren't looking at that condition correctly. So we were just trying to say as long as it doesn't hit 0, but the way our math works, we would never hit the right value for 0. So we have to have a way to create that flip to create that a negative result. So on page 70, we start looking at a couple of interesting things. Our brains interpret things as true and false, but our computer does it, and it does it a little differently. If I ask you to say, is banana equal true, what does that tell you? The computer's going to interpret that. So we need to start thinking about how are we going to evaluate values and numbers. The computer is going to say, oh yes, banana is true. There does exist something called a banana. So we're going to start working with Boolean logic. So I would ask that you read from page 70 and work your way through. Try to do these problems. Try to look at them. So we have not operators, all different kinds of operators. So we're going to work on some of these in class on Wednesday. We're also going to take a look at our problem for this week. So we have a very typical problem. We're also going to look at what is going to be required for the grade on that problem. So what am I going to look at for the grading? Is it just getting the correct answer? Or is it also having some structure in your code? And we're going to look at what I am going to look at on that. So if you haven't got the book out over the break, because I know everybody went out and was playing with Python over the break. No? Whale watching is better than Pythons. It could be. So make sure you look at that. Take a look at that over the next 2 days. Go in and as early as possible look at that discussion board and find some resources. You may well find they're helpful for your assignment this week even. So your assignment is in there, but I would ask that you wait until we discuss it on Wednesday before you post it. Some of you I know work so far ahead. And you guys are all like, no, not this week. We just got back from break. So, all right, let's go out. Have a great afternoon. Enjoy the rain. Yes.